All right, we're going to evaluate this definite integral, and we're going to use U substitution. And this one's a little tricky. One of the things you can do with U substitution is you can, when you see an exponent, e to a power, you let U equal that power. It doesn't always work, but once you think about that, you're thinking, okay, how about I'll just at least investigate. What if I let U equal 1 over x? Then you start investigating, is the derivative of 1 over x sitting around here somewhere? It's easier for me to see that if I break this up into the numerator times 1 over the denominator. All right, so this is, I'm thinking about, and I know that this is going to be U. Okay, I'm going to let U equal that right there. So U equals 1 over x, and I need to take the derivative of that. So that's should be written as x to the minus 1. And the derivative then is du equals negative 1 x to the minus 2 dx. I'm going to do two things. I'm going to multiply both sides by negative 1, so I have negative du equals positive x to the minus 2. But I'm also going to write x to the minus 2 as 1 over x squared. See? So the derivative of 1 over x is lying around. It's over here. That's negative du. And this 1 over x is, that's u. All right, so there's another thing I want to do is I want to change the bounds. When x is equal to 1, see, this is x equals 1 to x equals 2. When x equals 1, what does u equal? U is a function of x, it's 1 over x. So it's going to equal to 1 over 1, which is 1. When x equals 2, u is equal to 1 over 2. So let's just change everything then now. So this whole thing is equal to, let's use brown, the integral u equals, okay, x equals 1 corresponds to u equals 1. U equals 1 to, when x equals 2, u equals a half. Okay, so I have u equals 1 to u equals a half, e to the u times 1 over x squared dx, but that's equal to negative 1 du. So I have negative 1 to 1/2 e to the u du. There is no reason to substitute x back in after I integrate, because I have a definite integral with some bounds. I can just do this guy. I want to put the smaller number, the lesser number of 1/2 and 1. I want to put that on the bottom, so I'm going to flip. When I flip the bounds, I flip the sign. So when I put the 1/2 on the bottom, I change from negative to positive. That's optional. Don't have to do that, but I'm going to do it anyway. Okay. Antiderivative e to the u is e to the u. I'm going to evaluate from 1/2 to 1. So I get e to the 1 minus e to the 1/2. I would guess that the author would like me to don't want to upset the author, even though the author's not here, but I think they want to write that as a square root. Either way, both are completely legitimate and fine. All righty, any questions about that? Or anybody say, hey, that's wrong. Hey, I want to point something out, that e minus the square root of e is a positive number. That makes sense because e to the 1 over x squared is positive on the interval from negative 1 to 2, from 1 to 2. Actually, it's positive from 1 to 2. So, so that makes sense that our answer is positive. So if you get an integral that's negative, you might think, was my function negative on the interval? Okay, that's it.